Good morning, everyone. Thank you for attending today's event, the Great Developer event. My name is Saffi Ali. I'm a cloud solution architect at Microsoft. And in today's session, I will be talking about the DevSecOps practices using GitHub and how to complement that with Azure. But before talking about the content and deep dive into it, just a little bit of a reminder about the code of conduct. So these are the basic, practices and behaviors that is expected of all of the professionals attending these events. So just have a look at these and read through them, and you just a reminder. The other thing I just need to kind of remind you, there have been several organizations wanted to sponsor DDD, even though we have no costs to cover. As a result, we are donating to the National Museum of Computing, so who do such great work for the industry in general. Another thing I need to mention is thank you to all of the sponsors of today's event. So Sage Landmark, NDC, and Black Marble. Thank you so much for sponsoring today's event. And for you who are attending today, just make today's as interactive as possible. Tweet about it, chat about it. We have a Discord channel. If you have any questions, just feed them through there, and I'm more than happy to answer them, whether at the end of the presentation or during my talk. And without further ado, let's deep dive into the why of today's session. So basically, why we keep talking about security and DevSecOps nowadays seems to be a hot topic for everybody, organization big and small, and developers are expected to kind of not only worry about security, but actually implementing and reutilizing the best practices in terms of how to implement the better security. The reason for that is this is 3 days. It's the time that can take a vulnerability to be exploited. So from the time that you push a vulnerable code to your repository, to your public repository, it probably will take 3 days until it can be compromised and exploited and cause a lot of problems to you and your organization. And in order to remediate threats as early as possible, it's time to shift security left. You might have heard this shift left before, shift security left. It means shift the verification and the best practice as early as possible in the development life cycle. So many organizations are just beginning this kind of element of their transformation. And currently only 62 of enterprises don't integrate any security in the development phase. So basically developers do their job, and at the end there will be like an automated testing or smoke testing or very high level security testing. It's not really in the level of the code base itself. And further, 58 of the security and development teams don't collaborate on security, which is a big problem. There are a lot of, and working in the field, I can see that a lot of big organizations still have silos between teams, and everybody lives in their own silos and feel their own responsibility on their own day-to-day task and not necessarily collaborating together. And when organizations don't start security process early enough and involve all of the teams, they don't only lose the visibility across the business, but they also often take much longer to locate and remediate vulnerabilities, because there's no channels, there's no process to actually identify them in the first place. And when they actually identify them, it will take them a lot of time to actually remediate them. So shifting left help enterprises, organizations big and small, to find and remediate those vulnerabilities earlier and across the development lifecycle. So enterprises that extend the security to development will reduce security incident by 80%. 80%, that's a big number if they were able to shift the security as early as possible in the development lifecycle. And quite frankly, if you're able to fix it now in the development, it will be much cheaper, far cheaper to fix it now, rather than actually someone compromise it, whether this is a ransomware that happens with a lot of big companies recently, or just a normal government, expected government kind of nation state attacks, or something more sophisticated than that. So it is better to incorporate these practices as early as possible. And I think this is a recognition now. And that's why this introduced the concept of DevSecOps, and this is the benefit. So basically, if you're not, I'm sure you've heard the term DevOps many times, and that's the reason that you are attending today's session and track. But basically, the DevSecOps is is the evolution of DevOps, where company takes on security first mindset, putting security into every phase of the development lifecycle. So from the design of the solution to the delivery of that solution to the end customer. And when implementing these practices successfully, companies will gain both the speed of the DevOps practices and the holistic security and peace of mind that comes with DevSecOps. And this obviously will help those organizations to first reduce the remediation time by shifting security left, and integrate with the with the rest of the ecosystem to secure the existing tool chain. So it's not only about the code that you write, but also about the tool chain that you are introducing, as I will be diving in a little bit more details later, how the end-to-end process will work together. But how would you secure the software? So basically, normally it's the developers and the CISO, the CISOs. Those are the people responsible for the security best practices down the stack. But also developers now have responsibility and shared accountability with the CISOs to be able to run a more secure software and define a more secure software lifecycle. So development teams are all about speed and productivity. Generally, their teams have three main requirements. The first is to ensure developer velocity is maximized, so there are no limits in terms of the innovation and speed. So we as developers, we tend to, we need to ship things faster. We need to deliver value to our customer as soon as possible. But at the end of the day, we need to redefine and enhance the existing processes to include these security postures and security best practices within our workflow. The second is to put any increased complexity on the developer. And this is through the developer first tooling that's secure by design. So one of the very first thing that you need to think about is how to use the right tools at the right time in the process itself. So which IDE you use, which plugins that you are integrating with, and like Rob said in the earlier in the morning about how to secure the settings in the tool that you're using. So when you're using GitHub Action, how to make sure that this is not really a security vulnerability for the process itself. So you can secure the code, but the process can be compromised. So these are the things that we need to think about and we'll discuss later. So as you can see from this slide, obviously security is everyone's responsibility nowadays. So there's no single team or single person or single organization that is only responsible for security, and you basically ship the code, give it to them, and they will make the code secure. It's basically everybody from devs to security. And the Microsoft idea and the Microsoft platform in terms of unifying the DevSecOps solution relies on two main components: making sure that you are securing the developer workflow as code is being created, but also from a security operations standpoint, which tend to the code after it's deployed into production or the testing. So basically there are two elements, as I said. One is when you create the code, and the second when you actually push the code to the actual infrastructure that will run the code. These are the two main elements that we need to think as teams collectively how to mitigate the risks and the vulnerability that we can introduce to the life cycle. So let's dig into the development section first. So when you look at the Microsoft portfolio of solution, thanks to GitHub and Azure combined forces, if you start by Visual Studio Code, Visual Studio Code provides a virtual development environment for any developer, regardless of their local capabilities. And obviously, Visual Studio Code is the top one editor nowadays, and it's quite good that we have this tool. It's free, everyone can use it, and it's integrated, and it's agnostic regardless of which language and which platform that you use. Same goes with GitHub Codespaces capability. So GitHub Codespaces, I will be diving later in GitHub Codespaces. It is essential, an entire development lifecycle tool that's in the cloud that make it super easy to onboard new developers to your team. So instead of spending hours and sometimes days to create the dev box for the new developer, with Codespaces, it can be started in seconds instead of that amount of time. So not only it's efficient, but also it's a sandbox environment for the developer to test untrusted code. So instead of you introduce the code to your own network, to your own VMs that connects to your enterprise backbone, instead of you compromising that or introducing risk to that particular VM, using CodeHub CodeSpace is a completely sandbox environment outside of your network that anybody can use within your organization without actually compromising the existing security posture. And utilizing this kind of tool is essential to create that. So how to do that? So how to build a secure development lifecycle with DevSecOps? Obviously, these are the three main sections that you need to introduce and you need to revisit if you're already using DevSecOps. First one is how you secure the development environment. Second one, how to build and embed security in your developer workflow. So design, code, test, deploy, and operate and monitor. This is the typical developer workflow that we all work within. So how you make sure that you embed security every step of the way within that developer workflow. And the third aspect is how to bridge the gap or the divide across DevOps and DevSecOps team. So this unified DevSecOps solution makes it easier for organization to realize the core value of the DevSecOps. So let's talk about the first thing, how to secure your development machine, right? So how to secure the developer environment itself, because this is the first point of entry, right? This is the first point that the developer will download the code, go to GitHub, download an OSS-based framework or a solution, or using a sample code from whatever the cloud provider or whatever. So how you make sure that this is secure by design. So to be able to do that is basically for code browsing, you can limit the scope. So securing the development environment begins with securing all the cloud-based developer machine. So as I said, that means that we need to place more strict control on how developers interact with environments. So for code browsing, we should limit scope for non-trusted repositories to a browser sandbox, which can be easily enabled by design when you're creating the policies within GitHub. We also should only build non-trusted repositories in an isolated environment, not on a local developer machine, for the reason that I mentioned before. So you can't really download an untrusted repository to your local machine that is connected to your corp network, and that's really high risk, and the attack area around that it's most likely elevated attack area. So most likely developers have administrative rights on their machines, and if that's the case, they can really scroll and execute unintentionally by downloading these source codes locally to compromise the network. And the third aspect is identity policy management is important too, because as cloned repositories should implement at least privileged access principles. So not necessarily because you can read the repository, you can update it or introduce risk into it, which is quite obvious, but most of the time it's just sometimes missed or sometimes overest. The second thing is secure pipeline and infrastructure. This is really important, and I think all of us are really invested into that. You will also, in order to ensure the development security alongside developer velocity, we need to make sure to implement first a centrally governed and secured engineering system. Second, control so that only trusted, approved, and authorized DevOps pipeline and actors have the ability to enforce supply chain control. So as you can see from this slide, this is the SolarWinds attack breach. Someone has introduced, and as you can imagine, right now, hackers and attackers are not really attacking the code after you ship it as product. They actually introduced risk in the code base right now. So as you can see from this screenshot, they actually have a custom class, and that custom class has been introduced into the code base, and that's what gave them access to thousands and potentially millions of machines around the globe, even running in a mission critical workloads around the world. So securing the pipeline is a no-brainer. So these changes will fortify your organization against threats such as build tampering. So this is something called the SW breach. It's just an example of this. The second attack that could happen is unauthorized access to package repository or the production infrastructure. Again, like Rob said, like Rob showed you earlier in the morning, if you attended the first session, when you having these secure keys, one of the very obvious things that you can't store them in a plain text within your repository. But actually this can happen, and how you make sure that you have the right guardrails in place so this will never happen. No developer will be able to commit these things. And I will show you that how we will use CodeQL and Dependabot and the GitHub general advanced security to do that. But let's complete the first section, which is developer machine itself. So we have a developer tool now, which is the vscode.dev. So vscode.dev is an ability to run or to edit or to show code, edit code without actually being able to download that to your machine. It's like a sandbox environment to edit. It's a cloud-based IDE, not to run the application, but at least edit it. So this is the basic stuff. So if you have a repository on GitHub, for example, so you have few files, open the file, but basically the editor experience in GitHub, at the end of the day, this is not an IDE. But what if you can use an IDE, cloud-based IDE, to edit but not run it? But if you want to run it completely, run the code in a completely isolated sandbox, this is the usage of GitHub Codespaces. With GitHub Codespaces, you can launch Codespaces in the browser of your laptop or iPad or phone even, and you will be ready to code in seconds instead of spending hours or days to set up the dev environment. But it also, from a security standpoint, it provides the familiar tool and consistent experience for all of the project, regardless of what tool or what framework that you're using. But from a security standpoint, it helps you manage the user permissions, like who can use this particular or run this particular repository by giving them access. If they don't have access, they can't run or execute or clone it. With GBG verification, for example, you will make sure that commits are being verified and are made by trusted users. So no one will be able to kind of introduce, some sort of vulnerability to your code unless you first know them, you have access, and there is a GBG verification happening in place to make sure that those commits are being verified against your defined best practices, being scanned against known vulnerabilities, etc. So GitHub Codespaces is both an easy to use for developer, an easy to use developer box, but also it's a completely secure environment from a sandbox environment. It's a one single trackable source of truth that you can have encrypted secrets and manage your user permissions by using and utilizing GitHub Codespaces. So if I just share my other screen and just show you how that will work in action. So if I go to here, where is the other machine? Which is here. Hopefully you can see it. So basically, this is my repository. And as you can see here, this is my organization and this is the repository. Right now, if I need to edit any files in here, if I click on any file, obviously the normal one is just to edit that. But if I click edit to this file, basically it's not really a full rich experience to edit JSON here. But what I can do here is just change the domain from github.com to github.dev. And that will automatically change the whole repository to a full VS Code IDE in the cloud. I will have my own files everywhere. Just give it a second. I should see my files here, and if I need JSON. So, the JSON editing experience is much better now. So basically, it's a full VS Code in the cloud without me downloading or doing anything, so I can edit it. But the problem here is if I go to run and debug, this is still an IDE in the cloud, but I can't run it, right? So it needs some sort of compute to be able to run this code. So this is this is Tailwind, the famous Tailwind ASP.NET application that you might use before. But basically, in order for me to run that, I need a server to run this onto some sort of compute. So as you can see here, it says, well, I need a compute. Can you run it? And the answer for that is basically go and create a code space. So to create a code space, obviously code space should be enabled to your organization in the first place. And if you're not, you just go to GitHub/codespaces, sign up for your own code space environment. But basically you just click here in the code, select code space and just new code space. And as you can see here, you choose which machine type. You can choose, a beefy one or a very small one, like a 2-core or 4 cores. And this is exactly what I did. I have my my code space in already created. So if I click on that one, that will do pretty much what I have here. This is just the editor GitHub.dev, but this is my code space. So within seconds, I would be able to not only edit the files, but I will be able to run them in a sandbox environment, which is really important because by using code spaces, I don't have to download the files or the executable to my machine or to my corp network, so it can compromise the whole lot of the network, but I can run that in the cloud and I can interact with it when I'm interact with it from my local machine without having to download the code. So I think I'm overrunning a bit, but let's continue to what I want to cover. So this is GitHub code spaces. So what else that I need to kind of talk about today? So with GitHub code spaces, coding and having a developer box is fine, but we need to kind of secure the end-to-end developer workflow, right? So this is the next step. So we talked about how to secure the developer machine and developer experience, but let's secure the workflow, the process itself, the development lifecycle. And normally, each stage of the development lifecycle has a unique security component in it. So that when used together, help prevent the threats at all critical junctions. So starting with pre-commit, so it is important to start with a focus on threat modeling. So there are many tools in terms of threat modeling around there. So when you have in the very first stage of your design, in your architecture, you need to include the threat modeling by testing your design and your architecture against not known vulnerability, but known behaviors and known practices that can introduce threats to your entire organization or your solution, and understanding the threat landscape to grasp the overall risk when you are looking to bring to execution in code. So you can employ, as I said, a range of IDEs, security plugins to the security standards. So this step will also help you to ensure there are no vulnerabilities created unintentionally. We all need to create the best code, but basically introducing these guardrails early in the development lifecycle will make sure that this will not happen unintentionally in the future. So another thing that you need to mention, you need to incorporate is peer review and pre-commit hooks, right? So code reviews, it's just a no-brainer to align different teams about security risk and code that they are recently introduced to, which is, again, I've read a recent book around the psychological, we sometimes feel attached to the code that we've written, and we don't like to be kind of not criticized, but we feel like we've written the best code in the world. But basically, peer review in a good environment I can assure you that it will make the code better. Because basically having another peer review will make sure that you actually check all of the check boxes before you actually do the commit. The second step is the post commit, right? When it comes to the actual commit itself. So it's time to start thinking about more extensive security methods to review the code. So first one is static code analysis. Security unit test may involve running scanners or performing manual steps on the overall repository, and in that stage, you need to review the dependency. Again, Rob mentioned the Dependabot in the morning, but basically dependency management and the overall dependency tree for inherited vulnerability. So it is a saying that most of your code you actually didn't write. At least 90 to 99% of the code you actually didn't write, and that's why you will inherit all of these vulnerabilities. So that's why keep an eye on these vulnerabilities and make sure that there is a mitigation. The good thing about GitHub Advanced Security, for example, that with the Dependabot and CodeQL, you will do both the security scanning for the code, but also there's a big database that GitHub has that knows about known vulnerabilities across many tools and frameworks that can help you to kind of mitigate those risks. The third one is the deploy stage. So when you look at the overall health of the code base, and in addition to the item checked in the commit stage, which can be repeated in the deploy stage, we also look at the infrastructure as code. This is critical, right? Which are necessary for identifying abstracted layer of infrastructure. So in the deploy, you also need to examine the high-level security risk, cloud configuration checks, security acceptance test, to make sure that everything is in line with the expectation and the organization security goals. A good tool with that is the integration with Azure Policy and Azure Security Center. So for example, if you have a specific policy to say, no one will be able to deploy an API management unless it's within a VNet, right? So before you actually go and deploy, you will verify your ARM template, your PySub, your Terraform template against the policy, which is something I used to do in the Azure DevOps world, but in GitHub is as seamless as it has ever been. So basically, you would check your deployment against the existing policy before you actually do the deployment. And the same thing apply for any security policy that the organization defined in place. So this is for the deploy stage. So once code is deployed, so now you did all of the right things. You have a pre-commit threat modeling. You have a commit static code analysis. You have the security units scanning. You actually did the credential scanning against, someone has committed, codes or usernames or password to the code repository. And then when you actually deploy it, before you actually deploy that, you made everything correct by scanning and verifying your deployment against the policies. You make sure that there are cloud configuration in place, etc. But at the last stage, once you push your code is deployed. Now it's the matter of operating and monitoring through continuous monitoring and additional threat intelligence. Because you push the code, right? The code is running as a solution right now in production, but there are operation team that actually monitor that and sometimes changes the code. So you need to make sure that to hold additional post-mortem, as we say. So your team take your lesson learned and continue iterating as they move through the development lifecycle, but also it will prevent the actual deployment from deviating what it was intending to behave in the production environment, right? So these are the kind of the end-to-end development lifecycle. But the criteria for a successful DevSecOps, you need to involve the developer in the DevSecOps. And there are 3 things that need to be met in order to achieve that goal. First, making sure to provide developer first tooling to empower developers, which we already covered that by the likes of code.dev or GitHub code spaces. So you will enable them to be more cognizant of the security impacts of the code that they have created, right? And it's a combination of tools and general awareness. So a lot of people don't necessarily know that, open source is great, but it is equally your responsibility to make sure that this code that you're using is secure as well. It's your responsibility. Is not the maintainer only problem. It will be your problem as well. The second is to remove any friction for developers by providing data and building automated security capabilities. So when you define the right processes in place, you will give your teams much more agility in order for them to innovate. You put the guardrails, you will take the time to identify the guardrails in the correct way for the way that your organization work. And once you can spend a little bit of time into that stage, but once you do it, the developer velocity itself will be much simpler and things will go on the autopilot because, as long as you build well-defined processes in place that will make sure that the innovation will continue, but actually the security risks are to the minimum. The last thing is automation. Apply automation to all of these 3 different checks within the developer workflow on the day-to-day basis. And that's why it falls back to the definition of the policy. But how will we do that? How GitHub will help you with that? So with GitHub, there is the GitHub has a feature or a set of feature called the GitHub Advanced Security, and it's a community-driven approach, and it's composed of 3 main umbrellas of features. The first one is the dependency scanning. Second one is code scanning, and the third one is secret scanning. So with the code scanning, with the dependency scanning, I already covered that. It just gives you an idea of the risk and the level of the risk for your dependencies. So for example, if you're using a specific .NET version, very old, there is a known vulnerability in it. It will say, well, you're using this one, and potentially the fix for that is just upgrade. And the Dependabot will be able to help you to actually do the upgrade. You can have a pull request for that. It will create a pull request automatically for these risks. And within that pull request, it will identify the fixes for these things most of the time. Not all of the time, some of the things that would require manual intervention, and some of the things that you are using will potentially not have any fixes yet, right? So it's up to you to, fix it yourself or find a way or find an alternative, right? So this is the dependency scanning for how's your code is related to the rest of the ecosystem, but also how's your code related to your organization. So things like reviewing your code. So using pull request and the automated testing for the pull request is essential to that process. The second thing is code scanning. With code scanning, I think it's one of the best things that you can do by scanning your code for known, uncompliant or not really the good practices that you have to use. So the secret code, the secret source is this scan is being generated without any additional step to ask for code scanning to run. So all scan takes place and the results are published in the GitHub user interface. So the scan itself, it will be executed within your repository and the results will be there in a single interface. So if you go to your repository, there will be a security section. Within the security section, you will see the code scanning alerts. There's a section there that will tell you these are the security things that we think that you need to look at, but also it will, there's a concatenation of the dependency that can be correlated to those security scanning. And to complement that is the secret scanning. It's obvious, no one should hard code any credentials or tokens or JSON file that have sensitive credentials, but sometimes these can slip through the gate, right? So having security scanning enabled as well will make sure that you'll not only notified, but these things will not get exposed to the wider user. So if I go to the to make sure that you're using the security dependency, this is the GitHub advisory database, and how GitHub uses and verify the known vulnerability is that you want to know the dependency about the vulnerability. So dependency graph help you to understand your project dependency in the first place. It will say your code is using these frameworks, whether you know it or not. Believe me, sometimes you not even know that you're using this particular framework. You just use that, but this one that you're using is using other one. So this is first to identify your dependency, and second is to create an alerts for the vulnerable dependencies and the dependency updates it requires for that. And as I said, for maintainer, it will make sure that you have a security MD file with your policy, right? So you need to define a security MD file, and within the security MD file, you will define your policy for this particular repository. So how people will push things to your repository, what are the best practices that they need to follow, what are the things or checks that you need to include in order for you to accept their pull request. So this is a must for you to think about how to introduce the security MD files. Code scanning, I already covered that, but if you look at the screen on the right hand side, code scanning is using a code QL, and within code QL, as you can see here, it can identify things that is not really a good practices to involve, whether this is using hard-coded untrusted URLs as the slide shows here. So this one is just saying that you're having a server-side URL redirect. And these, by the way, these are automatically created for you. You just, the code QL, it runs as a GitHub action. It scan your code and generate the pull request for you to look at them. And I'll show that in just a second. For the similar thing is for credential scanning. So as you can see here, someone has put the blob storage connection string. So despite the fact that this is valid, but you can't have that in here. You can't have that stored in the file itself. So instead, you just integrate that with something like T-Vault or any secure credential location that you need to store them in place. But once you do that, once you have this security, you use the Dependabot, you use the code QL to scan your code, you enable the security scanning. But how about to orchestrate that to the end policy? So the things that I mentioned is how to integrate that with policy in this place. And one of the things that we introduce right now is the policy integration with Azure. So you can manage Azure policies as code from GitHub repository in an orchestrated manner. So that means for managing the Azure policy as code from GitHub repository, you can scan the container to look for common vulnerability in Docker images before pushing them to a container registry. So normally before that integration, we would have to scan the code, you have the container, and you push that to the container registry in Azure, and within there you will find the vulnerability. Right now, there is a native integration. When you build the image, before you push it to the container registry, this integration will scan the image in GitHub before it will get pushed to the repository. So again, it's another way to shift the security vulnerability left. So you as a developer solve it here and now and not wait until it's been exposed or being known by others. So enough me talking, and let's let me go and show you that in real life. If I go here, where is the other slide? Yeah, this is the one. Cool. So obviously this is my repository, right? And within that, within the repository, you just go to the security. And normally, if you haven't enabled these features, there will be like enable policy in place, enable these things here. But this is the security dashboard for all of the security vulnerability that you might have, potentially will have. No, but doesn't have a security. If you don't have a security vulnerability, you would be like a hero. And the whole idea of using that is just to test your code against the security vulnerability. But to enable that, you just go to first security and analysis. And this is how to enable first the dependency graph. So this will enable the Dependabot and understand the dependency. But the second one is Dependabot alert. So you can receive alerts about vulnerability that affect your dependency, not in here and now, but actually after you shift something to a repository. So let's say there is today there is no vulnerability for, let's say, .NET 4.5, but there will be in the future, right? Yeah. Rob says I know that, Ray, because Rob was working with us internally at Microsoft to deliver a bootcamp. Yes, this is exactly the repository, mate. The third one is the Dependabot security updates. Security updates means that it's an automated way of updating. So the Dependabot will pick up these vulnerability, but there is an automated way to fix these things. So Dependabot security updates, it can upgrade non-vulnerable dependencies. So if you have a .NET and there is a new one, it can update it to the latest version to give you a better security posture around it. And then we go to the advanced security scanning, code scanning, secret scanning, and custom pattern. So obviously, custom pattern is something for you to define your own custom policies in place to scan your code against something that you know specifically, or something that is not yet introduced or defined in the GitHub code scanning database. So with the code scanning, just detect common vulnerability and coding errors, things that is against the best practice that could affect the security, the overall security. Secret scanning is just obvious. It just scans for something that you written within your code, whether this is a connection string or a shared access signature, SAS token, all of these sort of things. To scan against it and just say, well, you need to remove that and save it somewhere else, right? So once you enable that, and let's see how it works in the real world. So if I go to security dashboard again, if I go to the Dependabot alert, so as you can see here, there's a whole lot of alerts happening here. So if I pick one of them, for example, so let's say the ANSI regex, for example, it gives you the alert, the description, and the remediation, right? So the remediation for this alert for this vulnerability is basically upgrading, which should be easy, right? So I can create a Dependabot security update for that, and that will automatically update my version manually. Update my version automatically to the next version or whatever version that they are suggesting. Same thing applied for code scanning. So for the code scanning, it says there is a high risk. It just picked up a high risk clear text logging of sensitive information. So let's have a look at this. So basically, I'm logging in this line. I'm logging the profile, which could have the profile name, the email, and potentially the password. I'm printing the entire profile object to the logs, right? So that's obviously something that I need to kind of mitigate, and fairly enough, it's highlighted as a high risk. I can create an issue. It's still open, and I have a pull request. So if I go to the pull request, I should see these pull requests against these security. So if I go to the path parse, for example, it say that this is it's automatically created by the Dependabot. It has the commit, it has the problem, and actually I solved this problem, and everything has passed, and all I need to do is just merge that pull request and just confirm the merge. So with enabling these kind of best practices within your own repository and potentially within the overall organization, that will put the right guardrails in place. So in the future, as part of your development lifecycle, you will have a better security. You'll not eliminate the security completely, but at least you have a well-defined processes in place that can pick them up at least, so you can reason about it, and not to figure that, you know, like after you finish and after you push that to your users or your customers. The last thing I want to show you is the CodeQL pipeline. So the CodeQL is the static code analysis runtime itself that runs against your code. So basically, it's it depends on your on the code within your repository. So as you can see here, because this code has Go, has JavaScript, and has Java and C#, so the 3 has passed, but the C# one seems to have the problem, and that's what the one that created the security vulnerability alert for me, right? And if you go to, if I go here, if I go to, not this guy, yeah, sorry, if I go to actions, right, CodeQL, I go to one of them and how it runs. So basically there's two jobs. The one thing I should highlight here is that the CodeQL actually picks up and automatically identify that this repository has JavaScript or C#. You don't have to configure anything. You just enable it and it will automatically run against it. But the one I need to show you is the set of tasks that is happening right now. So basically it looks like a normal action, right? It initializes the code QL against your code and against any dependency. It builds it, but actually then do a static code analysis for it. And the way it use it is basically use the cloud runners for actually download the CodeQL action itself to your repository and run your code and run the static code analysis against it. So pretty much it's the straightforward things. There is nothing hidden, and this is one of the things I like about the GitHub way of scanning code. There's nothing hidden. Yes, you configure it and it will automatically create it, but the actual process itself is pretty straightforward. And on top of that, there is a full history of what happened. So if, for example, one of these runs has picked up something that didn't collate it or created a pull request, you can automatically go here and visit and see what's happened or even rerun them when you need to. So the last thing I need to show you here is the integration with the container registry. I mentioned about the integration between GitHub and Azure, and how both of them can integrate together. And this is the security integration that I was saying, I was mentioning about. So within container registry right now, you can scan your code and your repository against known vulnerabilities within the actual container, right? It's not the repository, it's the container itself. So as you can see here, these are the things that has been discovered within my container registry, right? Normally, this process was basically you push your container to the registry and the registry will scan it against it. But now with the integration with GitHub, basically these checks will be very early in your checks rather than you pushing. So these things will get validated in the pipeline, not after you pushed it to the GitHub security. Sorry, after you pushed it to the container registry. So I have last few things that we need to cover, which is how to bridge the divide or potentially the relationship between different teams, which obviously is the hardest bit. Tooling is easy to grasp, easy to implement most of the time. The problem is to define the shared responsibility paradigm across different teams and different people within your organization, right? So as we think about shifting from centralized security team to including developers as accountable, we need to shift from having a centralized security team to a culture of security or as a shared responsibility. So you start by aligning on the right metrics to measure. So as you can see from this slide, you can have the security policy makers defining these policies and security researchers. This will feed back to the centralized security teams, which obviously what's happening right now. But that will feed back down to the security community of practices, the blue-green the red-blue teams, the security testing labs. But these practices will need to feed back to different development teams. So within that development teams, there should be that expertise and that awareness and that understanding about these security attack areas, security vulnerabilities that you need to be aware of, and how to build right processes in place to mitigate them. So as you can see here, this bridges the gap between who's creating the policy, who are testing the policies, and who will be implementing those policies early in the development lifecycle. So the development team will be very early to implement that, but the security team will be the one that govern and guide and enhance the process end to end. So sharing the accountability, just to make sure things are clear. It is important to focus on measuring only the most critical and important KPIs. So historically, developers have tracked deployment and shipping speed associated with pipeline throughput. But along with pipeline throughput, it is important to focus on metrics that deal with live site health, right? Not everybody, take these kind of metrics seriously, but generally the most critical metrics to track are time to detect vulnerability, time to communicate these vulnerability, and time to mitigate them. These are three important metrics that we need to include as part of your measurement. The DevOps practice need to measure as well. Time to detect, time to communicate, and time to mitigate. These are the things that you need to include that now if you're not already doing that. The things in your slide, time to build, time to test, time to deploy are already fine, but you need to think about the security KPIs as well, whether this is from the pipeline throughput or the live site health itself. I'll leave you with something else, which is I already covered that, but basically, in summary, just as a reminder, in order for you to kickstart your DevOps process and practice, you need first to secure the development environment, whether you are using Codespaces or whatever else, but in my opinion, Codespace is just a no-brainer, but you need to secure the development environment. Second, you need to define the developer workflow in the right way. The third thing is you need to bridge the divide between DevOps and the SecOps teams. So the SecOps will feed those policies, those practices, those information to their implementation team. But at the same time, this information need to feed back as part of the developer workflow itself, so it can be automated, it can be verified against, and it can be measured. Lastly, if you need to learn more about this, all of what I just said today, we have a good DevOps practice in terms of the security DevSecOps book here. I'll share the slide afterwards, but this book is really a great book, and I learned a lot from it in terms of how I implement and advise customers in terms of how to move from an ITSM model to a more DevSecOps organization, and how to have a heterogeneous teams within their practice generally, and how to move from this rigid and siloed way to a more modern. The second thing is, if you need to learn more about GitHub Advanced Security, it's already there. If you just search for github.com/security, it should have all of the information about that. And with that, I don't want to take more of your time, but thank you again for attending my session. And if you need any questions, you can reach out to me at Discord or at LinkedIn. Thank you.